Two identical long current carrying wires are bent into the shapes shown in the following figures. If the magnitude of the magnetic fields at the centers P and Q of a semicircular arc as B1 and B2 respectively, then the ratio B1 by B2 is. So here basically the question is belongs to the magnetic field that we need to calculate for a straight infinite current carrying wire. We can write B equals to the general formula B equals to mu 0 I by 4 pi r, where r is the distance, into sine phi 2 plus sine phi 1. So here you can see at this point is basically the at the end point of a infinitely long current carrying wire. So for an infinitely long current carrying wire, we know phi 2 equals to 90 degree and phi 1 equals to 0 degree. Therefore, we can write B equals to mu 0 I by 4 pi r. Okay, so there have two current carrying wires, and at this point means there are 2 points. That means in both the point we have the value of mu 0 I by 4 pi r. Now for what will happen for the semicircular arc? Semicircular arc is similar to what is the value of the magnetic field at the center of a circular loop. So if we know the value, then we can easily write this, that is B equals to mu 0 I by 2r. But since this is for a semicircle, then you can write mu 0 I by 4r. So therefore at point P, we can write the magnetic fields are B equals to mu 0 I by 4 pi r plus for this part. Now for the semicircular part or arc, we have mu 0 I by 4r. Now for the next part, we have mu 0 I by 4 pi r. So we take a common of mu 0 I by 4r. We can write 2 by pi plus 1 equals to mu 0 I by 4r into 2 plus pi by pi. So this is for the first case. Now we want to see what will happen for this next case. So in the next case, as you can see, at this same point, we have the same value, that is the magnetic field at Q. You can write B equals to mu 0 I by 4 pi r. Now for the semicircular arc, mu 0 I by 4 r. Now what about for this point? As you can see, according to Biot-Savart law, we know that if the dl vector, or we can write that dv vector proportional to mu 0 I dl vector cross r vector by r cube. So dl vector cross r vector, that means we can say that if the angle between dl vector and r vector is 90 degree, then only we can write the Biot-Savart law. Or if it is not, say 0 degree, because cross product is nothing but the sine theta. Now if theta is more than 0 degree, then only we can have a value of magnetic field at this point. But here you can see dl vector along this line, the segment, and r is also along this line. That means the angle between them is 0 degree. Therefore for this part the magnetic field will be 0. So only two terms are there, and we can write 0 equals to, again if I take a common of mu 0 by 4r, then we have 1 by pi plus 1 equals to mu 0 I by 4r into 1 plus pi by 1. So according to the question, if you want to put the value of b1 and b2 into the ratio, that is b1 by b2, then we can simply say that mu 0 I by 4r will be cancelled out. If I write b1 and if I write it as a b2, then only 2 plus pi and 1 plus pi will remain. So that means according to the option number 1 is right. That is 2 plus pi by 1 plus pi. Thank you.